My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 455. In this lecture, we will try to understand calibration plots. So let us understand a plot called a calibration plot, which will helps us a lot in building calibration models. We are trying to predict probability of yq equal to 1 given xq. Before we are going to calibration plot, let's understand the steps of constructing it. Then we will see nice example of calibration plots. So first of all, we already have a model f which is trained on dtrain. Now given that I have a cross-validate data set DCV, let's assume my DCV is bunch of xi comma yi points. I have already used my dtrain to build my model f. DCV is the data set that I have. First step that I will do is this. Remember, for each point xi in my D cross validate, I can send this xi through this function f. This f which will, what is this function f or model f? It will return yi cap, which is nothing but f of xi. So I am trying to construct a data set like this. For each point in DCV, I will construct a table like this. What is this table? Remember, xi comma yi hat comma yi. Remember, yi hat or yi cap is f of xi. What the model returns? Model returns yi. This is yi is f of xi is f of xi is nothing but yi cap. What the model returns? What is this yi? Yi is true class label. This yi hat is model return value, that is f of xi. Here we are looking at two class classification. What is this two class classification? Let me assume my yi belongs to 0 comma 1, isn't it? Is it not two class classification? Yes. We will get a table like this. This is x1 y1 cap comma y1, x2 y2 comma y2 cap comma y2. This is table which consists of your data points. Xi is data point, f of xi, that is yi cap, and your actual true label is yi. This is the first step. Build a table. This is building this table. It is step 1. Within the same step, second part, that what we will do is sort this table in increasing order of yi cap. You have to sort this table in increasing order of yi cap, means this one. You have to sort this, isn't it? Sort this table in increasing order of yi cap. So literally what I am doing here, I take my table here and I sort in such a way that I have let's say x1 y1 y1 hat y1, after that x2 y2 hat y2, like this, isn't it? After sorting, let's assume after sorting, let's assume that I have this table. I sorted it in such a way that your y1 hat is less than or equal to y2 hat is less than or equal to y3 hat. I sorted it on yi hat. And what is my yi hat? Which is nothing but f of xi. Let me say this is step 2. Let's go to step 3. I will break my table into chunks of size m. Let me assume m equal to 100. Now what will I do? I break my table into pieces. My first 100 points into one bucket or one chunk, my second 100 points into second chunk. Here I have x1, y1 cap and y1, and x2, y2 cap and y2, so on, x100, y cap 100, comma y100. Basically, it is a chunk of size 100, that is m equal to 100. Similarly, you get x101, y cap 101, y101, so on, x200, y cap 200 and y200. So in my third chunk here it could be x201, y cap 201, y200 up to x300, y cap 300, y300. We have three chunks. Each of these chunks are of size m. Next thing we will do here, for each chunk here, average yi cap. What is this? Average yi cap, and we will also calculate average yi. How do you calculate average yi cap? We will take all these values. Which values we will take? We will take all these values and sum them up and divide by 100, isn't it? So it is 1 by m into sigma I equal to 1 to m yi. That is, I think I can say y cap of 1. 1 means this one indicates it is chunk 1, isn't it? In the first chunk. Similarly, what is the average of yi's? This is average of yi's, 1 by m sigma I equal to 1 to m y. That is, this one indicates first chunk average of y's. Average of y's, this is average of y's in first chunk. Similarly, I compute average for second chunk, isn't it? I can compute average for second chunk. Just see, how can I calculate? This is for second chunk. This is y cap values. This is for actual labels. In similar manner, I can calculate, isn't it? For second chunk, y cap of 2 and y2. Similarly, y cap of 3. What is this? Y cap of 3, y3. I will keep computing y cap of 3, y3, and I will keep continuing this process. Let's assume our data set D cross validation has 10,000 points. Let me assume this particular data set DCV has got 10,000 points, isn't it? How many chunks can I break it? What is the size of each chunk? Each chunk size is 100. Therefore, 10,000 by 100. Therefore, how many chunks I will get? I will get 100 chunks. So, I will get 100 pairs, 100 such pairs. I will get 100 pairs. For example, here I have 3 chunks. This is one pair, this is another pair, this is another pair. I am getting 3 pairs for 3 chunks. If I have 100 chunks, I will get 100 pairs. So I will get 100 such pairs. What are these pairs literally? Remember, all these y1 cap, y2 cap are sorted. Your yi cap are sorted. Let's not forget this. These chunks are basically saying for the first 100 points, when you sorted in increasing order of yi cap, the average yi cap is like this. What is average yi cap? This is first one, isn't it? But the true yi average, the true average yi is y cap of y of 1, isn't it? The average predicted value for second chunk, average predicted value for second chunk is this one, isn't it? And true average value is this one, isn't it? This is what we have. Now the data for calibration is basically, what is your data for calibration? Data for calibration is basically, this is y cap of I, comma yi. What is my y cap of I? That is average of f of xi. yi is probability of yi equal to 1 given xi, isn't it? Yes, this is the data that you have for calibration, that is y cap of I, comma yi. This is the data that we have for calibration. Look at what we have to achieve. what we have to achieve with calibration? What is the probability of y equal to 1 given xi? What does it mean? Let's assume it is a binary classification. Let's assume 30 points in this, in 30 points in what is this? Let's assume 30 points in this are 30 points in this are 1. Ones in actual labels are 1. Therefore, what is the probability? 30 by 100, that is 0.3. Y, what is this? Your y1 is 0.3, which is actually is a true probability. If your model is doing good job, then your, what is this? Y cap of 1 is less than or equal to y cap of 2 less than or equal to, implies y1 less than or equal to y2 less than or equal to, so on. If your model is doing anything sensible, if it is true, I can say your model is sensible. This data set, what is this data set? This data set is called calibration data set. So given this calibration data set, there is something like something called calibration plot, which is very interesting concept that we use a lot. In calibration plot, what we do is, this is our x-axis. On x-axis in calibration plot, what we do is this: our x-axis is for y cap of I, which is average value of yi cap. Here your y-axis is yi, which is averages of yi's. This is actual probability of yi equal to 1 given xi's. That is probability of yi equal to 1 given xi's, which is average of yi's is yi, isn't it? Because remember, yi's are 1 or 0. So average of yi's tells you what fraction of points are ones. That's why I give example of 30 points in my first chunk. 30 points are positive and 70 points are 0 value. That we get here is 0.3, which is actually a probability of finding a 1 in this region of y's, that is first chunk. So when I plot this, what is the data set? What is the data set that I am plotting? The data set I am plotting is capital D equal to, what is my data set? Actually, this is in my data set. Actually, what is my data set? This is my data set. Y cap of I, comma, yi. This is y cap of I is on the x-axis. Yi is on y-axis. Let's assume this is my first point. Let's assume this is my first point, isn't it? This is my second point, third point, fourth point, fifth point, sixth point, so on. Ideally, how should this look? Ideally, these points are lie. Yes. Ideally, how should this look? Ideally, these points are lie on 45 degrees line. This line. Ideally, these points must lie on 45 degrees line. If this is 45 degrees, this is 45 degrees line. Suppose if a point, let me say, ideally these points must lie on 45 degrees line, isn't it? If a point lies here means, if a point lies here, what does it mean? If a point lies here means average of yi cap that model gives, and this length, this length must be equal to this length, isn't it? The average of yi cap that model gave, and this length is same as this length. That's what this means, isn't it? If a cross is here, if a point is here, what it means is there is actually a chunk in your data. Let's say our chunk is y cap of 2 comma y of 2, y2. What it means in chunk 2, this 2 indicates chunk 2. In chunk 2, if I take all yi cap, I predicted, if I take the average values of them, what is average values of yi's? Your average values of yi's and your average values of yi cap, they are exactly equal in chunk 2 if 100 points, if in chunk 2 of 100 points. So in an ideal model which does not require calibration, we'll have all these points. We'll have all these points on 45 degrees line. This is the ideal line, but in reality you never come across ideal line. In reality it may be like this, isn't it? In reality you never come across ideal line. The task of calibration is, given this data set decalibration, given this data set decalibration y cap of I comma yi, you somehow need to map your y cap of I to yi. It is like a table. It is like a table. Just see, it's like a table. What is the yi cap value is 0.2, and your let me say your yi cap value is 0.2. Then let me assume your yi cap is 0.2, yi is 0.5, and yi cap is 1.2, and yi is 1.0, yi cap is 1.6. Y cap and your yi is 1. Let me assume y cap of I is 1.9, your yi is 1.8, your y cap of I is 2.4, your yi is 2.5. Let it be. You are given a two variables, isn't it? Your model takes xq. Your model takes xq and it returns yq. On top of it, you are building calibration model to predict your probability value, isn't it? It is similar to this. This is similar to this one. This is similar to this one. This one is similar to this one. Actually there is a mapping, I can say. Just see, this is similar to this. This is similar to this, this is similar to this, isn't it? Your calibration is basically taking this number. Your calibration is basically, this calibration is basically taking this number 0.2 and generates output, and generates output. So in reality, this is how lot of calibration plots look like. This is 45 degree. This 45 degrees line. What is this dotted line? This is 45 degrees line from sklearn. Your 45 degrees line is ideal line. On real world problem, when I apply logistic regression, they got this blue line. When we apply naive Bayes, they got this orange line. When we apply random forest, they got red line. When we apply support vector classification, we got this green line. One thing you notice here, look at this. What is your x-axis? X-axis is average of yi cap, and y-axis is fraction of positive, or in other words, average yi's. So you know that your model is doing good, because look at all these curves as they increase on x-axis, and also increase on y-axis. This is important. Let's see these 2 points. Let's see these 2 points, these two values. If your yi cap values are larger, corresponding average yi also larger. So all these curves are monotonic. Curves. Now the whole challenge of calibration boils down to this. You are given y cap of I. And you have to predict yi. Isn't it? This is like a standard regression problem. It's a regression problem. With only one feature. Just go through this lecture. If you have any difficulty, please keep a comment. Thank you very much.